Our universe is filled with stars, giant balls of burning gas that light up the cosmos. Deep within these stars, a process called nuclear fusion releases incredible amounts of energy. We've harnessed a tiny bit of that power here on Earth using fission, splitting atoms instead of fusing them. Now, imagine a future where our energy comes from a source even safer and cleaner than what we have today. That source is thorium. Thorium is a weakly radioactive metal found in rocks and soil all over the world. It's actually more common than uranium, the element used in most nuclear power plants today. But thorium itself isn't directly usable as fuel. It needs to be transformed into uranium-233 inside a special type of reactor. This might sound complicated, but the process is incredibly efficient. Thorium produces far less radioactive waste than uranium, and the waste it does produce decays much faster, meaning it's safer to handle and store. Plus, thorium reactors are inherently resistant to meltdowns, making them incredibly safe. Let's compare thorium to uranium, the workhorse of today's nuclear power. Uranium reactors can produce plutonium, a material used in nuclear weapons. This raises serious concerns about proliferation and the potential for misuse. Thorium, on the other hand, is unsuitable for weapons production, making it a much more peaceful energy source. Another major advantage of thorium is its waste profile. Uranium reactors generate highly radioactive waste that remains dangerous for thousands of years. This waste requires careful storage and management, posing significant environmental challenges. Thorium, in contrast, produces waste that decays to safe levels within centuries, dramatically reducing the long-term risks. Furthermore, thorium is incredibly energy-dense. Just 1 ton of thorium can produce as much energy as 200 tons of uranium or 4 million tons of coal. This means we would need far less thorium to generate the same amount of power, reducing mining and transportation needs. So how do these amazing thorium reactors actually work? The process starts with bombarding thorium with neutrons in a reactor. This bombardment transforms thorium into uranium-233, the actual fuel that sustains the nuclear chain reaction. The heat generated from this reaction then powers turbines, producing electricity just like in conventional nuclear power plants. One promising type of thorium reactor is called a molten salt reactor. In these reactors, the fuel is dissolved in a molten salt mixture, which acts as both the coolant and a means to contain the reaction. This design enhances safety by allowing the fuel to expand and contract with temperature changes, preventing dangerous pressure buildups. The potential applications of thorium energy extend far beyond just power plants. Imagine ships and submarines powered by thorium reactors, capable of sailing around the world for decades without refueling. Thorium could also revolutionize aviation, enabling the development of aircraft with significantly extended ranges and reduced emissions. And while it might sound like science fiction, even thorium-powered cars have been envisioned, offering a future of clean and sustainable transportation. Thorium represents a remarkable opportunity to harness the power of the atom in a safer, cleaner, and more sustainable way. It's a game changer in our quest for a future free from fossil fuels and their harmful effects on our planet. As we continue to explore the cosmos, seeking answers to fundamental questions about our universe, let's also remember to look inward towards innovative solutions like thorium that can help us create a brighter future here on Earth. As we stand on the brink of a new era in energy innovation, thorium presents itself not only as a solution, but as a beacon of hope. The journey to fully realize thorium's potential is filled with challenges, from technological advancements to regulatory hurdles. But with every challenge comes an opportunity for progress and collaboration. Governments, scientists, and industries around the world are beginning to recognize the immense promise of thorium. Research and pilot projects are already underway, laying the groundwork for a cleaner, more sustainable future. Imagine a world where our energy needs are met without compromising the health of our planet or the well-being of future generations. The transition won't happen overnight, but with collective effort and determination, we can pave the way for a thorium-powered world. It's time to invest in the research, support the policies, and embrace the innovations that will make this vision a reality. Countries like India, China and Norway have already embarked on thorium research, paving the way for global advancements. Please like and subscribe to our YouTube channel for more content on clean energy and innovative solutions. Thank you for watching.